The tattoo machine. With the help of a needle that moves back and forth, the tattoo machine pierces the skin and deposits tiny drops of ink about 1.5 millimeters below the surface of the skin. Since it takes 28,000 perforations to fill 5 square centimeters of skin with ink, the tattoo machine works fast. Incredibly fast. To get the job done, it relies on 2 very powerful factors: the elasticity of metal and electromagnetism. All that to poke the skin 100 times per second. The tattoo machine. The needle. This goes up and down, piercing the skin. The foot switch, which starts and stops the machine. And the variable voltage power supply unit, which controls the force with which the needle pierces the skin when the foot switch is pressed down. Taken apart, it's obvious to see the tattoo machine is an electric circuit. Current comes in through the positive terminal, passes through 2 coils made of copper wire, and then a contact screw. It continues across 2 metal strips and exits through the negative terminal. To move the needle, the tattoo machine relies on electromagnetic force. When electric current passes through a copper coil, it's magnetized. It becomes an electromagnet. That's exactly what happens to the 2 coils in the tattoo machine. Right above the 2 coils is the armature bar, a piece of metal with a rod attached to it. At the end of the rod is the needle. When electricity transforms the 2 coils into electromagnets, they attract the armature bar thanks to electromagnetism. The force of attraction is powerful enough to bend the normally rigid metal strip to which the armature bar is attached. The result? The armature bar moves downward and sticks to the coils, bringing the rod with it, along with the needle at its tip. And the hole is pierced in the skin. 1 hole. By pulling the armature bar down, the electromagnetic force breaks the connection between the contact screw and the metal strip. The result? Electricity stops circulating. No more electricity in the electromagnets means the coils instantly become ordinary coils again, no longer able to exert electromagnetic attraction force. Because this metal is both extremely rigid and elastic at the same time, the strip to which the armature bar is attached immediately regains its shape, like a spring. The needle comes up, pulled by the metal strip. This cycle is immediately repeated because as it moves upward, the armature bar renews the connection between the contact screw and the metal strip. Once again, allowing electricity to flow. The coils become electromagnets again. The electromagnetic force attracts the armature bar, and all of this goes on at breakneck speed. This battle between electromagnetism pulling and the elasticity of metal pulling upwards continues to move the needle for as long as the tattoo machine's foot switch is being pressed. As devices go, the tattoo machine is both simple and elegant. Simple because it's a basic electric circuit that's closed and opened over and over again. Elegant because it's the tattoo machine itself that cuts and re-establishes the circuit. All that to move a needle that pokes the skin. A masterpiece.